All right, good morning, everybody. It is almost time for a nice holiday to break up the time between the semester and finals. We'll still come back for one more action-packed week after we get back. Just in terms of thinking ahead a little bit, let me talk to you about what the shape of things is going to look like when we get back. So, once we get back, I'm going to assign your final project. So that'll be assigned on Monday the 2nd. It'll be due 2 weeks later on the 16th. And that project is going to be worth 20% of your final grade. So you're going to want to make sure that you're ready to make some space to really put a lot of work into that and do a really nice job with that. Exam 2 will be the Wednesday after break. Definitely not the Monday after break. That would have been vindictive.
Disastrous. That would be disastrous.
Well, it all depends on your point of view. But yeah, that would be needlessly vindictive. So on the 2nd, so that Monday after Thanksgiving break is over, I'm going to spend part of the period going over the final project, what I want you to do for that, what my expectations are, and so forth. That final project then is due on the 16th. And then I'm going to, and so what's the significance of the 16th? The 9th is the last day of classes, and the 16th is the final exam period for this class. So then I will also spend some of the period doing some review in preparation for exam 2. So exam 2 is going to focus on most of what we've learned since exam 1. So I'm going to have questions about basically all of these data structures. So looking ahead, you need to be ready to answer questions about heaps, about sorting, skip lists, binary search trees, tries, and hash tables. And a major theme is going to be the idea of the big O notation and thinking about how much computation these different data structures and algorithms require in different kinds of situations. So that's all stuff to be prepared for that exam 2, which will be coming up on the 4th. So like I said, I'm going to spend some time on Monday the 2nd reviewing a lot of those ideas with you, making sure that they're fresh and that they're clear. Lab on the 3rd is going to be focused on doing work on your final projects. So there's not going to be a formal Lab 13. Instead, I will expect everyone to be there, and I'll expect you to have a concept for your final project, and I'll expect you to be doing some work on it. And I'm looking forward to spending some time on that Tuesday, visiting with each of you about what you're doing for the final project and what your overall strategy for the final project is going to look like. Yes?
Can the final project be a partner thing? Or?
No, it is strictly individual.
Okay, I'm just curious about that.
Then your curiosity is satiated.
Okay, thank you.
Yeah. So that's what's coming. So that'll be Monday, Tuesday, Wednesday, and then Friday class and Monday class will involve thinking about the concept of how do you design a large program? What are some key components in thinking about how a program is decomposed into classes in a way that keeps it manageable and intelligible? And so that's going to be a major theme that we'll be exploring on that Friday and that Monday as we make it towards the end of classes. And that same theme we're going to talk about today, in fact. So to motivate this, I want to spend some time thinking about the project you are currently working on, Project 4, the adventure project. So the structure of the project as such is dictated by the configuration files, the content files that you receive describing how an adventure is to be laid out. And one of the goals I have for you all in this project is for you all to spend some time wrestling with the concept of how do I represent this? How do I structure my program so that I can make as tractable as possible the process of finding the data I need to find when I need to find it? So, in light of that, let's think about some scenarios here and think about how that might motivate some design. So, in order to navigate through this adventure world, what is the information we need to have? Suggestions? What do we need to know to navigate the world?
Well, for one, we need to know the map location.
Okay, we need to know a map location. What else do we need to know? Yep, so we need to know some destinations. Okay. Is that it, or we need to know anything else? Yep. So closely related, we need to know some exits. Yeah. Anything else come to mind?
Items there.
Okay. Paxton, are you going to say something?
Portability of the items.
Yeah, items and their portability. Good. So these are some good things to start with. So we're going to now start thinking about some design considerations. So what might code look like that supports these things? So map location, of course, is essential. We need to have some way of representing where am I? Okay. And so when we think about representing where am I,
We use map.string.job as map. Whatever they're called, object, string.objects, or comment objects to, find that.
that didn't make any sense at all.
I forgot what they're called. They're they're not the brackets and they're not parentheses, but they're I forgot.
So you're talking about syntax.
Yeah.
We're not talking about syntax
I
here.
know,
We're talking concept. We
I
need to
know.
think at a higher level.
I know. I'm thinking of the name of the object, the name of what a map location is. It's usually called maps.
So let's retreat from what you're talking about for the moment
Okay.
and try to think in a more conceptual way. I have to have a representation of where I am. I also have to have a notion of how that representation is being stored or understood. In other words, if we even pose something as simple as where am I, the real notion we need to have is what is the overall state of the game. And so this is the sort of thing that happens in essentially any game you would ever design, is you need to have a way of representing what's the current state of the game. If I am playing a video game like Asteroids, the state of the game includes stuff like the orientation of my spaceship, the positions of the rocks, the missiles that I've fired. So at any specific moment in time, the game has a certain defined state. Note that this applies to any kind of video game regardless of how smooth the animation might appear to be. That is, the state of the game transitions through a series of discrete events. So you have a state that changes as a result of discrete events. In fact, you can think of any game as effectively being what we would call a discrete event simulation. That is, you've got a simulation of some world, some reality. And that simulation advances not in a continuous way, but in a series of discrete time steps. At each time step, the state of the simulation changes in some way. Now, something that makes something like asteroids maybe more complicated than something like adventure is the idea that at each discrete state, there are multiple entities that are all changing on each step, right? So we're not only dealing with the impact of the player navigating with some controls, we're also dealing with the fact that the asteroids have a predetermined motion or predetermined movement. So at each time step of the simulation, we have to have a data structure that keeps all of that stuff up to date. So we'll come back to adventure in a moment. For now, let's actually think about something like asteroids and think about how that's structured as a data structure. And we're going to come back and apply some of those lessons with adventure. So if I think about a game like Asteroids, by the way, anybody know how old Asteroid is?
Asteroids are really old. It's like one of the first few.
Yeah, 70s. Yeah, like solidly in my childhood. And the oldest form of it used a form of graphics known as vector graphics. And so everything was just lines drawn on the screen. It looked really cool. Then I got an Atari 2600, and that used pixel-based graphics. And suddenly they went from black and white outlines to brightly colored asteroids. In any event,
that was a wake-up call, probably.
it was just all fun. It was all good. So the state elements are going to include my spaceship, asteroids, any missiles I've fired, and of course that UFO that comes through and fires at you. So what you could imagine is that you have some class representing the game state, and within that class, you've got elements that refer to each of these things. Now, the ship would just be direct because you've only got one of them. But the asteroids and missiles are another matter. What kind of data structure do you all think we would use to represent the asteroids and missiles?
Probably for asteroids, I would say a hash table because you'd have to store a location for them.
So you would hash based on the XY coordinates?
Yeah. And those XY coordinates would change depending on how it moves.
That would be an unlikely representation, actually.
It was an idea.
But it was an idea, and I do appreciate that.
The array counselor.
Yeah, we would probably use an array or a linked list. And the reason is, on every step of the discrete simulation, we have to visit every single object, right? That's not something hash tables are optimized for, right? Hash tables are about, given a large amount of stuff, find it quickly given the key. In this case, we're visiting every item on every step. So yeah, you would use an array or a linked list. What would be pros and cons of arrays versus linked lists for representing the asteroids? Any thoughts?
Say again, I'm sorry.
Pros and cons of arrays or linked lists for representing the asteroids and the missiles.
Linked list could we basically could go through different linked lists could easily be modified to for you. Are we talking like individual asteroids or just?
Each asteroid is an element of a list or an array.
Yeah, that's what I'm thinking.
Yeah, Jake.
Well, with the array, you have random access.
Okay, and what benefit does that provide?
You don't have to go through every single asteroid to get to the one that you want to. So you can kind of just
Yeah.
choose one.
The trick, though, right, is that we don't actually need to do that, right? Because on every step of the every discrete time step, we actually have to visit every asteroid in order to update its location based on its motion vector. So conceptually, at least, there might be some benefit to thinking of these in terms of a linked list, especially because when they get destroyed, it's cheap for removal. Now, you wind up doing a nested loop when you do this sort of thing. So for every asteroid, you check every missile and you see if they happen to be colliding with each other. And if they are, then you remove both of them from their respective lists. So that would be a way we could think about it. The point is, we need to have some kind of top-level class that knows everything about the game and then organizes all of the data so that it's easy to find relative to what you need to know at every time step. So in light of that, what I would suggest is for something like the adventure game, we also need a notion of a class that represents the state of the discrete event simulation. That is, when we talk about representing the state, we have a notion of the location of the player, and then we also have a notion of rooms, generally speaking. And we'll come back to that idea in a moment. Coming back over here, in order to keep the representation coherent, each of these items itself could be modeled as a class, right? So what you would want to avoid in your game state is something like an instance variable list along the following lines. Int ship X, ship Y, double ship heading, and so forth. Right, it's pretty easy to imagine building this representation using low-level representations of each of these constituent aspects. So this is what you want to avoid in your game state class. Instead, stuff like this belongs in a ship class. So you want to think, as you're working on the design, how can I take components that I'm throwing into some big game class and break them into pieces that represent subunits of what I'm doing? This overall approach to thinking about design is essential to make any large system work. Otherwise, what happens is that your mind becomes overwhelmed with low-level details as you seek to reason through what the game state could be doing. If you don't do this, something like game state can be something known as a God class. And I don't say this to be irreverent, by no means. But this is the term. That is, a God class has all of the properties of a God. Omniscient, omnipotent, all-knowing, all-powerful.
Isn't the God class usually the main class?
You don't want a God class.
Oh. Okay, I didn't understand how to.
Yeah, a God class is a bad thing. It winds up being too much detail to handle mentally. It doesn't need to be omniscient and know every last detail. It doesn't need to be omnipotent and take care of managing every last detail. For instance, if we think about rotating the ship, changing its angle, that should be a method in the ship class. So you might have a method like rotate, and then it might take some parameter indicating how it rotates. But the mathematical calculations necessary for the rotation really ought to happen in the ship class. You wouldn't want that code to be in the game state class. That's starting to make it omnipotent. Far too powerful for a class. So this decomposing of the whole thing into smaller bite-sized pieces is an essential aspect of building a coherent design. And in the end, I think you'll find it's a remarkably sanity-preserving mechanism. So now if we think about adventure, okay, okay, that thing went away. Okay, good. At the top level, the game state is really just about where is my adventurer and where are the rooms? And it doesn't have to be anything more detailed than that. But the details are certainly there. They're just within classes that represent those details at the appropriate level of granularity. So let's think about location, for example. There are a couple of ways we can reason about this, but something that's going to be absolutely essential is you're going to need to have some kind of location class. Now, what's going to go in that class, we can see from the nature of the data that we actually receive, right? So a location needs to have an identifier, a name, a description, a long description, its exits, and then items that are within it as well. And all of that is proper to a location. So in contrast, let me talk about a more dubious design for a game state. You could imagine trying to do something like the following, and this would be quite bad. Go away. Okay, there we go. So, for instance, you could imagine having a whole bunch of hash maps. And so you have some hash map for the name to its exit list. Then you could have another hash map, that's the name, to the description. Then you could have another hash map, that's the name, to the long description. So you see, this would be an approach that would lead to a very verbose game state class. It could be made to work. I'm certainly not ruling that out. But these are all things that really pertain to being in a location. So a saner arrangement is to imagine having a rooms that is then a map from a name to a location object. And so from the game state, given the name of a room, you can find out everything you need to know about it. This in turn leads to a couple of alternative possible representations for your player. It could just be the location object itself, or it could be a string, which we then ask our rooms to give us the location. And that doesn't really matter very much. You know, you can go with whatever is conceptually most straightforward for you. But this simple separation of the game state consists of the adventurer is somewhere, and we have a way of thinking about where everywhere is, does make for a nice top-level design that keeps things fairly cohesive. Yes?
Question, how would you call a string? How would you call a location based on string?
You just put the string into the hash map and get the location out.
Okay, so like if you were to give like maybe like an ID, if you were to try to find an ID from maybe like a set of exits.
Right. Yes.
Okay, I'm thinking about one of my other.
Yeah. Yeah. So that then starts to break down things into pieces that are a bit more comprehensible. Let's look at other stuff that is being represented. So we could imagine our location. We need to have an ID, and that ID is maybe the keys in our hash map. But the object itself would want to know its own ID as well. And then it's got the full name and description and long description. And these are used when you're telling the player about the room. And then the exits. What kind of a data type do you all think you would use within a location for the exits?
I know when I was working on mine, that you had to call it the exits first from the so you would do like location.get exits, and then it would get like a list, I think. Or another,
So you had a list of exits?
well, it either give that or a hash map, I think.
Well, what do you all think would be preferable for representing the exits, a list or a hash map?
Probably a hash map, because it's another string, set of exits. It's just another set of keys.
Yeah, I think a hash map would be a little more useful, right? Because it presents the correct abstraction. You've got a direction and then a destination that emerges from that direction. So you could imagine within your location class having a hash map, for instance.
Question.
Yeah.
Question. This is another question concerning it. How do you pull item? How do you pull a hash map? How do you pull like a hash? How do you like within another hash map? How do you pull the information from a hash? So like exits.get, you just and like look or get get dot or get parentheses exits. You've done all that. How would you pull like say west from that? Because
You use the get method on the hash map.
so set it to a variable maybe.
This is a pretty low level concern, right? I can't even answer this question without looking at it embedded in some code.
Okay.
We're trying to think more abstractly.
Okay,
at the
I'm
moment.
sorry. I was just thinking about my
Okay, yeah. So coming back here then, we know that locations are going to have some strings in them, right? So here you do have strings that include the name, the description, and the long description. We also know we'll have a map that gives us direction to other location names, for instance. So we have that. What we also have, we have something else, right? What's that other thing we've got? The items, right? So the items themselves then are kind of begging to be a class, right? If we look at everything in an item, there's an awful lot going on. And so that too starts to sound like a class. In our location, then we probably have some kind of list of items, of item objects, each of which is an instance, of the item class. And so this in turn has a name, the aliases, a description, a goal, so the ID of a location where it's supposed to go. And here I think it would be easier just to hang on to the name of the location, and that way you can just use the map in the game state to resolve it to a concrete object. And the goal message and a score, all of that winds up being proper to an item. Now, once we have the existence of items, it suggests something else about our game state, which is we not only need the location of the adventurer, but we also need a notion of inventory. Now, think about how we progressed. We didn't even think about inventory initially. All we thought about initially was location and rooms. That is, you can put something together that's end-to-end functional that completely ignores items, right? As long as you've got a notion of location and rooms, you've got an adventure with which a human can interact. The inventory, the items, that's just sort of gravy on top, right? It's just another feature that gets added on. And this too is something very important about a large program. Every large program is simply a small program to which stuff has been added. So you want to, with any large project, absolutely as quickly as possible, have a complete running, or an incomplete but operational program. That is something that accepts input and gives output, even if it doesn't have very much of the functionality. But you always want to have a running program to which you can add features as you go. And just about all large software projects are of this form. If you even think about, an interesting example of this is something like the Linux operating system. That actually started as a school project, obviously from a very good student. But he just wanted to understand better how operating systems worked. So he wrote about 5,000 lines of code, and he had a workable operating system. It wasn't actually, good at that point, but it worked. It could run the hardware on a computer. And before long, it was about 10,000 lines. Let's see how many it is now.
Is that Linux like an open source one?
Oh, yeah. Number of lines. Yeah, it's up to 12 million. But the first version that he released to the public had 10,000 lines. Okay? You should draw comfort from this, right? You can do this. And the key ingredient to doing this is always having a running program. You don't want to front load like a ton of code and then try to get it all working at once. Instead, you want to build incrementally. And that was one of the goals of having the intermediate deadline on this project, was to encourage you to think that way. You always want to build incrementally, get stuff working, and then add more stuff as you go. That gives you far better chances of having a working program. I mean, maybe you are mentally strong enough to have every detail coordinated perfectly in your head and create in a single session of coding mania a final working program before you test it for the first time. I'm here to tell you that my own brain is not nearly so strong. My mind is weak and needs to be augmented by the machine. That is, code a little bit and then make observations to see, is the code that I created matching what was in my head? And then incrementally build it from there. And that's the key to actually getting code to work. You can't just sort of do it all at once. And so we see an example of this here. You get your adventure navigating, and that's all you try to do initially. Just get him moving around. Only then, once that works perfectly, do you even think about inventory. So what does that mean in terms of processing input? Well, what it means in terms of processing input is that the first time you process any input, you wind up ignoring a lot of it. Yeah, Caleb. Okay, yeah. So in my first iteration through this assignment, for example, I only paid attention to the data that was essential for the basic functionality. So for each of these, let's talk about essential, not essential. So ID, essential, not essential.
Essential.
Yeah. Name, essential, not essential.
Essential.
So here's the way we can think about it, right? What's essential is that you have one of these, name, description, or long description. You have to have some way of the user knowing that they're in a room, but you only need one of them. Exits, essential, not essential. Essential. Items, essential, not essential. Not essential. So look how much we can ignore, right? If we just grab the ID, the name, and the exits, that's all we need initially. And then you go back and you start thinking about, well, how do I extract the rest of the stuff from the input? So in a first rendition of a program, you're welcome to ignore a significant part of the requirements. Not because they aren't important, but because they aren't essential to have something that runs. So you start with something that runs, and then you add to it incrementally. And that is what actually gets a program working. And this is an iterative process. So for instance, I might go ahead and start working on items before I even do anything with long description. Yeah, it's kind of gravy, right? You know. So I go and I start working on items, and now I again ask myself, what's essential? The name, is that essential? Yeah. The aliases, is that essential? Not really. Aliases are just a convenience mechanism for the player. You do want them, but to make sure that the basic functions work, you don't really need it. Description, essential, not essential. Not essential. The goal. So the goal is tricky, right? Ultimately, I would call the goal higher priority than the description in terms of the game functionality. But I could imagine having an inventory and picking things up without thinking about the issue of the goal. So this comes to another issue, which is that you have to prioritize. In other words, and this is a life skill, by the way. Like, if you've got a to-do list with 20 items, it can be very easy to be overwhelmed. What you need to do is scan the list and figure out which is the most critical thing to get done right now. You find that most critical thing, and then you do it right now. And now you've gone from 20 to 19 items. The same thing happens with software. Your to-do list can be a mile long. You have to ask yourself, what is the next thing I need to get working and then integrate into my already continuously working program? And that's what you work on. Now, interrelated with this is that, whoops, where do we go? This game state class over here needs to be independent of I/O. It needs to be independent of I/O. That is, you should be able to update the game state and get information about the game state through method calls. And the reason for that is if you make it independent of I/O, it means you can write unit tests for it. And being able to write unit tests for it is valuable for when you keep adding functionality to make sure you haven't broken what already works. Furthermore, there's a lot of value in initially testing it strictly with unit tests. For one thing, it is a lot less tedious than manual testing. So if, for example, you've got unit tests that let you check to see whether you move from one location to another correctly, you can imagine building a set of unit tests that navigate the user through 5 or 6 rooms, right? Having done that, you then make sure they're at the correct destination. Hitting one button and then ensuring that the user made it to their destination correctly is a lot simpler than manually typing go here, go there, go wherever over and over again, right? So there is some extra work on the front end to write the unit tests, but in the end, you wind up saving yourself a huge amount of effort. When I'm coding something big like this, I often try to integrate my debugging directly into my unit tests. That is, I'll write the test and make sure it passes the test before I even hook it up to my I/O. And if it's buggy, I'll debug it directly in the unit test. Then when it's time to do my I/O, all I really have to do is take my command, parse it, and turn that parsed result directly into method calls. So that's just a very nice, simple step. For output, I just do a get on my game state, which tells me the location, route, or whatever, and then I can just print it. But by breaking off my game state into its own thing, I can make sure it's returning the correct strings whenever I need it. And that, too, goes a long way to make the software development process tractable. Now, you want to think about that in terms of nested levels, by which I mean, I mentioned over here, at some point you're going to create an item class. Well, guess what? You can do unit tests directly on your item class as well to make sure that it does the right thing. And it might turn out, in fact, that your inventory then turns out to be a class. Why is that? Because then you can write a method like, give me my total score or whatever. There are, what's the total value of what I'm carrying? That sort of a thing. You might even start by making your inventory just an array of the items you're holding. And that might be fine at the start, but then as the program evolves, you might find, I keep doing things to this whole array, and then you find yourself extracting a new class. So another thing to keep in mind about design is design can change over time. Start with the simplest design that gets your work done, but then if you find that too much is going on in a class or whatever, maybe it's time to break it apart, break something out into a new class. And this particular project has enough going on that you're going to have multiple opportunities to do this and think about it. In the end, I don't expect all of you to have the same design. Each of you will take your own approach and come up with different ways of decomposing the problem. But these are principles I want you thinking about as you undertake your design, as you dive in. If you don't think in these terms, it can be pretty tempting to write the entire program in a single giant main that's 300 lines. And part of what I'm wanting you to internalize here is that this approach is, in fact, insane. It's too much detail to track. Now, you might start with something like this, but the minute you find yourself overwhelmed with detail, you need to think about, how do I introduce abstractions so that I can actually keep this mentally under control? In other words, a way we can think about methods is that we want them to be short. So here are a couple of guidelines. First of all, if a method is so big that you can't actually see the whole thing at one time on one screen, it is definitely too big, right? Any method where you have to scroll to keep track of what's happening is too long, guaranteed. Now, why am I so insistent on this point? A method should be a calculation that you can visualize in your short-term memory all at once. If you have to scroll to look at it, you can't do it. It's not possible. But is that really short enough? I mean, of course, it depends on your font and it depends on your screen size. But what it really depends on is this fundamental idea of, can I hold the algorithm in my short-term memory? You ask yourself that question. You might spend some time writing it. You've kept it under a screen full. You feel very proud. But then you look at it, it's indented like 4 levels in a couple of places, and you're looking at it, and it just kind of feels like noise, you know, because there's so many details, and you can't keep track of them. That's a symptom that it's time to decompose it further, you know. So personally, I like to have lots of small methods, each of which has a name that clearly describes what the underlying algorithm is. Lots and lots of small methods. And at every level where I begin to be overwhelmed by details, it's time to introduce a new abstraction. So when I say introduce a new abstraction, well, it depends on the type of the details. So if I'm overwhelmed with algorithmic details, then I need helper methods. If I'm overwhelmed with details about data, I need smaller classes. I need to create more classes to represent those pieces of data. A way you can think about whether a class is any good is the concept of cohesion. What does that mean? It means most methods touch most of the data. So the data all works together in some way. If you find that you've got a class where it's like half the methods deal with one bit of data, one collection of items, and there are some other methods that deal with a different collection, that's a pretty good sign that it's time to split it into 2 classes. Yeah. This idea of cohesion is not a formal idea, a rigorous idea, or even an infallible idea. It's a guideline. It's just a way to think about, did I cram too much into this class?
Sometimes you've got to cram a lot just to get something to work. Well, in the sense of, if it's tied to that class, it should stay in that class.
Well, it all comes back to this idea. Do most of the methods touch most of the data? And if you find you can separate your methods into families, each of which deal with kind of independent parts of the data, it's time to split it. And in general, you're going to find that if something winds up with too much data. So earlier, for instance, when I was talking about asteroids, which was somewhere around here. Yeah, here we go. We had the notion of directly representing the ship X, ship Y, and ship heading in the game state. So if you've got that, and then you've got the UFO X and Y, those are different things that clearly belong in different classes. The methods are not going to overlap very much, right? So in general, stuff doesn't tend to interrelate equally or evenly. There are always data cliques that form, so to speak. And a lot of a good design is identifying those cliques and seeing, how can I pull this out and give it a coherent name? So as you finish working on this project, and especially looking ahead to the next one, I want you all to keep thinking about these ideas and thinking about how you can make these ideas work for you to help you keep mental control of what's happening in your code. So I, unfortunately, am not going to be around much over the next couple of days. Namely, as of this afternoon, I will be getting on a plane once all of my classes are over. Tuesdays, my only class is the lab, and we don't run labs on part weeks, so I'll just be gone. So good luck on your projects. Work hard, and I really look forward to seeing what you all come up with.